Imagine a planet drifting through the vast emptiness of space, with no sun to orbit, no warmth to sustain life, and no fixed home. These are rogue planets, celestial objects that travel alone through the universe, detached from any star system. Unlike Earth, which orbits the sun, rogue planets wander through space, untethered, moving in darkness. But how do they form? Can they support life? And what do they tell us about the hidden mysteries of the cosmos? What are rogue planets? Rogue planets, also called free-floating planets or interstellar planets, are planets that do not orbit a star. Instead, they travel through space independently. Scientists believe that these planets could be as common as, or even more numerous than stars in the Milky Way. Some estimates suggest that for every star in the galaxy, there might be 2 or more rogue planets floating freely. Unlike traditional planets that follow predictable orbits around a sun, rogue planets drift aimlessly through space, sometimes for billions of years. They are invisible to the naked eye, making them extremely difficult to detect. However, new technologies and observational methods have allowed scientists to discover more of these wandering worlds. How do rogue planets form? There are 2 main theories about how rogue planets come into existence. 1. Ejected from their star systems. Many rogue planets were likely formed within a star system, but were later ejected due to gravitational interactions. In young solar systems, planets often experience chaotic movements. If a giant planet, like Jupiter, forms close to a smaller one, the strong gravity of the larger planet can throw the smaller planet out into deep space. This process, called gravitational slingshot, can send planets flying away from their original system, making them rogue planets. 2. Born without a star. Some rogue planets may have formed directly from interstellar gas and dust, just like stars do. However, unlike stars, these planets never gained enough mass to start nuclear fusion, the process that makes stars shine. Instead, they remain as dark, cold planetary bodies wandering the galaxy. 3. Can rogue planets support life? At first glance, rogue planets might seem like the least likely places to host life. Without a star, these planets don't receive the warmth and light needed to support Earth-like conditions. However, scientists believe that some rogue planets might still be capable of supporting life under the right conditions. 1. Internal heat. Some large rogue planets might generate their own heat through geothermal activity. Just like Earth's core remains hot due to radioactive decay, rogue planets could have underground oceans heated by internal energy. If this is the case, life could potentially survive in these deep, warm environments, similar to life found near hydrothermal vents in Earth's oceans. 2. Thick atmospheres. A rogue planet with a dense atmosphere could trap enough heat to keep liquid water on its surface. For example, Titan, one of Saturn's moons, has a thick atmosphere that retains heat. If a rogue planet had a similar atmosphere rich in greenhouse gases, it could stay warm even without a sun. 3. Subsurface oceans. Some icy moons in our solar system, like Europa, Jupiter's moon, and Enceladus, Saturn's moon, have vast underground oceans beneath their frozen surfaces. If a rogue planet had a similar structure, it might have an ocean hidden beneath thick ice, providing a possible habitat for life. How do we detect rogue planets? Since rogue planets do not emit light and don't orbit a bright star, they are extremely difficult to observe. However, astronomers have developed advanced techniques to detect them. 1. Gravitational microlensing. When a rogue planet passes in front of a distant star, it bends and magnifies the star's light due to its gravity. This effect, called gravitational microlensing, allows scientists to spot rogue planets. 2. Infrared observations. Some young rogue planets still retain heat from their formation, making them detectable in infrared light. Telescopes like the James Webb Space Telescope, JWST, are helping scientists find more rogue planets by detecting their faint heat signatures. 3. Radio signals from magnetospheres. Some planets have strong magnetic fields that produce radio waves. Future missions may use radio telescopes to detect these signals from rogue planets. Why are rogue planets important? Studying rogue planets helps us understand how common planets are in the universe, If rogue planets outnumber stars, it changes our understanding of planetary formation. The potential for life beyond Earth. If rogue planets can sustain life, then habitable worlds may be more widespread than we thought. The history of our own solar system, learning about rogue planets, can reveal whether any planets were ejected from our system in the past. Could Earth become a rogue planet? While it may seem like science fiction, some theories suggest that Earth could one day become a rogue planet. If a massive object, like a passing star or black hole, came too close to our solar system, it could disturb planetary orbits and potentially eject Earth into space. However, this is highly unlikely to happen anytime soon. Rogue planets are some of the most mysterious and intriguing objects in the universe. These lonely wanderers, drifting through the darkness, may hold secrets about planetary formation, the potential for alien life, and the hidden forces shaping the cosmos. With advancements in space telescopes and observational techniques, scientists are on the verge of uncovering more of these cosmic nomads. Perhaps, one day, we might even send a mission to explore a rogue planet up close, unlocking the secrets of these fascinating worlds that drift between the stars. Would you like to live on a rogue planet? Let us know in the comments.